Hello, this is the second video on the series of videos on advanced calculus. So in this second video, we're going to go over some of the preliminaries required for us to get things started. And starting from the third video, we're going to get to the main material. So this video, in the first part of the video, we're going to deal with properties of real numbers. There are several properties of real numbers that distinguish them from other numbers. First, we're going to establish properties of real numbers that they are in common with other types of numbers. And second, we're going to talk about two properties that distinguish them with other types of numbers. So the first types of properties are field axioms. As it is clear from the name, the word field applies to other types of numbers as well. So what are field properties? Field properties are properties that are exclusive to addition and multiplication. So the first property is that addition is associative. So a plus b plus c is equal to a plus parentheses b plus c. And the same is true for multiplication. So multiplication is also associative. Addition and multiplication are also commutative. So that's the second property. The third property is existence of numbers 0 and 1. So what does that mean? It means there are numbers 0 and 1 that if you add a to 0 and if you multiply a by 1, you get the same number a. The third one is additive inverse. If you take a real number, there's always negative a, which means there's always a number d that a plus d is equal to 0. That is called additive inverse. The next property is that if you have a non-zero number, it has a multiplicative inverse, which means there's some d that ad equals 1. And finally, the last property is the one that relates these two operations. We have two binary operations here, addition and multiplication. So far in these properties, there were no relation between them. This last property relates the two operations, which tells us if you multiply a by b plus c, it is the same as multiplying a by b, multiplying a by c, and then adding them up. And that is called the distributive property. So there are a lot of different sets that satisfy these properties. And any set that satisfies these properties is called a field. For example, set of real numbers satisfies these properties. However, set of integers doesn't satisfy these properties, right? Because, for example, for set of integers, we don't have this property. So 2 is an integer, but 1/2 is not. But set of rationals does satisfy all of these properties again. Set of irrationals doesn't satisfy these properties because if you take two irrational numbers, when you add them up, you get something, you could get something that is rational. So square root of 2 is irrational, negative square root of 2 is irrational. When you add them, you get 0, which is rational. So any field, any set that satisfies these properties is called a field. Now, what distinguishes real numbers from other fields are the following axioms. The next axiom is what we call positivity axiom, which means the set of positive numbers makes sense. What is the set of positive numbers? To put that more rigorously, the set of positive numbers is a set P such that it is closed under addition and multiplication. So in other words, if you take two numbers in P, then AB, two numbers A and B in P, then AB and A plus B are both in P. The next property of the positive numbers is every number that you take, every real number that you take, every real number A, either A is 0 or A is positive or negative A is positive. And finally, the property, but again, if you look at this property, this axiom, rational numbers also satisfy this axiom. What distinguishes rational numbers from real numbers is the completeness axiom. And that essentially tells us that if you take a look at real numbers, there is no hole inside real numbers. And that's called the completeness axiom. Now, this is something we will discuss in our next video. Okay, so these properties are very important to know, and you are certainly familiar with them, except for the completeness axiom, which we will discuss next time. Okay, so as I said, before we can get started with the main material, we also need to talk about some of the basic properties of real numbers. The next property, or the next set of tools that we're going to build is inequalities. Basics of inequalities relies on positive numbers or positivity axiom. So here is the definition of inequality first. So if you take two real numbers a and b, we say a is more than b or b is less than a. Those are the same thing. As long as a minus b is a positive number. And we say a is greater than or equal to b or b is less than or equal to a if a is greater than b or a is equal to b. So these two notations are the ones that we're going to be using. And as I said, you are familiar with these concepts. So for simplicity, instead of writing down a less than b and b less than c, we write down a less than b less than c. And similar notations for a less than or equal to b less than or equal to c, and a less than or equal to b less than c, and a less than b less than or equal to c. So we can combine different inequalities. Next definition is definition of real numbers. Definition of absolute value of a real number. So absolute value of a real number is real number x is x if x is greater than or equal to 0, and negative x if x is less than 0. And as you see, the numbering here is not quite, doesn't quite follow. But if you look at the digital notes that I have posted, you will see more definitions and a more complete discussion of everything that you need for this class. Some of them are more basic, so I have omitted them from these videos, like what are integers, what are natural numbers, and things of that sort. But we will go over the main ones. Theorem, the first theorem we're going to go over now is the triangle inequality. This is something that I'm going to actually go over the proof. So what does the triangle inequality tell us? It tells us that for every two real numbers a and b, absolute value of a plus b is less than or equal to absolute value of a plus absolute value of b. So we are going to prove this theorem. Since we are dealing with absolute values, we would have to know whether a and b are positive or not. Okay, so there are several cases we need to take. Before I take any cases, let's consider the fact that since a and b are interchangeable, there's a symmetry between a and b, we can assume that one of them is less than the other. So let's assume, without loss of generality, a is greater than or equal to b, because again, it is symmetric. So there are several cases that we can take. Let's look at case one. Either both of these two numbers are positive. So let's say a greater than or equal to b, greater than or equal to c. In that case, absolute value of a plus b is, since both a and b are non-negative, absolute value of a plus b is going to be a plus b, which is clearly the same as absolute value of a plus absolute value of b. So this proves the first case. The second case is if 0 is between a and b. So a is greater than or equal to 0, greater than or equal to b. If that is the case, then I would not need to know what is absolute value of a plus b. So if I look at absolute value of a plus b, I don't know exactly what absolute value of a plus b is. So I need to also know whether a plus b is positive or a plus b is negative. So I'm going to take a sub case here. Basically, I'm going to assume that a plus b is also positive. If that is the case, if that were the case, then this would be a plus b. And this would be absolute value of a plus, okay, so this one is b. So b is negative. So I can write it down as, greater than or equal to absolute value of, I'm sorry, less than or equal to, yeah, less than or equal to absolute value of a plus absolute value of b. Because this is absolute value, this is a, and this is negative. And of course, negative b is more than b or equal to b, because negative b is non-positive, but b is non-negative. Negative b is non-negative, but b is non-positive. So that's the second case. The third case is if 0 is between a and b, and a plus b is negative, or yeah, negative. So that gives us, if I look at a plus b, that's negative. So that's negative a plus b. And I would like to compare this one. So I would like to compare this one with absolute value of a plus absolute value of b. Absolute value of a plus absolute value of b is a is positive, so that's a, and b is negative, so that's negative b. So I would like to see if this is true. And this is, if I distribute this one, I can see this is negative a minus b. And of course, this is less than or equal to this, since a is non-negative. So that's the third case. And finally, the last case is when both of these two numbers are negative. And if that were to be the case, then absolute value of a plus b would be, that's negative, so that's negative absolute value of a plus b. And absolute value of a plus absolute value of b is negative a plus negative. And this means absolute value of a plus b is equal to absolute value of a plus absolute value of b. And this completes the proof. Okay, so you can avoid, and anytime I complete the proof, I put a score at the end of the proof. You can avoid some of this casework if you were to kind of be a little bit more clever and replace a and b by negative a and negative b. You can avoid some of the casework that I did. Other ways of doing that would be to square both sides, and then use properties of inequalities for squaring both sides of an inequality. There are other more simpler ways of doing this proof, but I wanted to keep it to the basics. Okay, so that's a very important property of inequalities. That's a very important inequality. Absolute value of a plus b is less than or equal to absolute value of a plus absolute value of b. Very important inequality, and we're going to keep using that throughout the course. Okay, here are some identities. These three identities are also very important, and we're going to keep using them throughout this course. The first and second identities that are in theorem 0.6 are related to difference of nth powers and difference of sum of nth powers. So for every two real numbers a and b, and every positive integer n, a to the n minus b to the n is a minus b, parentheses, a to the n minus 1 plus a to the n minus 2b plus, etc., all the way to b to the n minus 1. As you see, the exponent of a keeps decreasing and exponent of b keeps increasing. A special case of that is the difference of square equality. So you have seen this identity before. And of course, difference of cubes is also something that you have seen in algebra. Now, if n is odd, then we can also talk about sum of nth powers. And all we need to do is to replace b by negative b. And we're going to get a plus b here, a squared minus ab plus b squared, if I replace b by negative b. So a to the n plus b to the n has a similar identity. It can be factored as a plus b times a large parentheses, similar to the above, except that the signs alternate from positive to negative, and the last sign is ultimately positive. Note that it is very important to check the fact that n is odd. Otherwise, this identity is not valid. So the next identity is geometric series sum. So when you add in terms of a geometric sequence, we're going to get a geometric sum or a geometric series. And the way I remember this is often by the first term. So this is the first term minus after last. This is the after last term. The last term is a r to the power of n minus 1. So this one is this one is after last, divided by 1 minus common ratio. And of course, r is the common ratio here. So that's the way I remember this formula. First term minus after last term divided by 1 minus common ratio. And finally, the next equality that we're going to be using quite extensively is the binomial theorem. And that, again, something that you must have seen in other maybe pre-calculus course. Essentially, it comes from the Pascal's triangle. A plus b to the power of n is a to the n plus n choose 1, a to the n minus 1b, all the way to n choose n minus 1, a b to the n minus 1 plus b to the n. Okay, so the next theorem is on properties of inequalities. If you have 4 real numbers a, b, c, d, then we have these properties. So there are a lot of properties. I'm going to quickly go through them. The first one tells you that if you have an inequality and you multiply both sides by a positive number, then the inequality doesn't change. The next one tells you if you're multiplying by a negative number, then you have to flip the direction of inequality. Next one tells you the transitivity of inequalities. If you have a greater than b and b greater than c, then a would be greater than c. Next one gives you the additive property, which means you can add two inequalities. You cannot subtract two inequalities, but you can add them. You can also multiply two inequalities as long as everything is positive. Next inequality seems pretty simple, but of course, in a rigorous mathematical course, you would need to make sure that you are proving everything. And all of these inequalities have proofs, and they are listed in the notes. Yet 1 is greater than 0, so that's the next inequality. The next inequality is that if you take a positive number, then its reciprocal is also positive. And if you take a negative number, then its reciprocal is negative. Next one is if you take an inequality and both of the numbers are positive, so their product is positive, or both of them are negative, so again, the product is negative, positive, then you can take the reciprocal of both sides, take the multiplicative inverse of both sides, but you have to be careful. You have to flip the direction of inequality. So if A is greater than B, 1 over A is less than 1 over B, assuming that both A and B are positive or both A and B are negative. Next inequality is called the trivial inequality. This is also one of those inequalities that is pretty useful to know. If you take an A real number, any real number, when you square it, you get something that is greater than or equal to 0. In fact, any real number raised to an even power is greater than or equal to 0. Okay, next one is product of a negative number and another negative number is positive. So if A and B are negative, then AB is positive. So that's the next one. Next one tells us that if you have an inequality, you can raise both sides of the inequality to an exponent, to a natural number exponent. Next one tells us that if you have A and B that are negative, A greater than B and they're both negative, then when you raise it to power of an even number, the direction of inequality is going to be flipped. And if you raise it to a power of an odd number, then the direction does not change. Next one is talking about basically the converse of those two, the reverse of those two. If an is less than b to the n, then what we can get is that absolute value of a is less than absolute value of b, assuming that n is even. And if you have an odd exponent, then you can just drop it. A to the n less than b to the n implies a is less than b and vice versa. So if and only if means both directions are valid. Next one is talking about how to open up inequalities involving absolute values. If b minus c, if a minus c is less than b, then you can get a is between c minus b and c plus b. So this is the inequality that we can get from here, and vice versa, of course. And the last two parts are if a is less than b and they are both negative, then absolute value of a is more than absolute value of b. So if you have two negative numbers, the one that is smaller has larger absolute value. And finally, it is always the case that precisely one of these three inequalities holds. Either a is greater than b, or a is less than b, or a is equal to b. And that again follows from the positivity axiom. Okay, so this brings me to almost the end of this video. The last thing I'm going to talk about is methods of proof. And this is mostly just a reminder. There are two different methods of proof that you need to be able to use. The first one is mathematical induction, and the second one is proof by contradiction. We did examples on this in the previous video, but I would also encourage you to look at the notes, the digital notes, that I will be also posting a link to the digital notes in the description of the video. So make sure you use the digital notes and to get a better understanding of the different methods of proof. Method of proof by induction and proof by contradiction. And of course, direct proof is an important tool to have at your disposal. So this brings me to the end of this video. If you would like to continue with this class, the exciting part of the course, exciting part of the class is going to start, in fact, from the next video, because that's going to be the main part of the class. So what we're going to do next time is we're going to start talking about completeness axiom. The completeness axiom is something that distinguishes real numbers from rationals. So feel free to subscribe to the channel if you want to continue with the videos of this class. I will see you in the next video.